Welcome to the Deep Dive. Today we're heading way out there into the solar system. We're checking in on NASA's Juno spacecraft.
That's right, focusing on Jupiter and Juno's ongoing mission.
We've got some, well, pretty interesting reports detailing some recent events with the spacecraft. And our mission here is really to understand, what happened. Why does it matter for space exploration?
And what does it tell us about operating in these really, really extreme environments?
Absolutely. And just to kick things off, think about this. We built this incredibly complex machine and then deliberately sent it flying through the most intense radiation zone in the whole solar system.
It's kind of mind-boggling when you put it like that.
It really is. It's like, I don't know, designing a super delicate robot and then, boom, throwing it into a cosmic blender. That's the kind of challenge Juno deals with constantly.
That's a vivid way to describe it. And recently, that cosmic blender seems to have kicked things up a notch for Juno.
Okay, what happened?
Well, the main story is that back on April 4th, during its 71st close flyby of Jupiter.
Perijove 71, right, the closest point in its orbit.
Exactly, Perijove.
Yeah.
During that pass, Juno actually entered a protective state called safe mode.
Okay.
And not just once, but twice.
Twice, on the same flyby.
Yeah.
Okay, let's unpack that. Safe mode. What does that actually mean for a spacecraft like Juno? It sounds a bit concerning.
Well, actually, in space mission terms, it's a really smart and necessary feature. Think of it as like an automated self-preservation instinct.
Oh, okay.
When Juno senses conditions that might be harmful, maybe high radiation or some other anomaly, it proactively puts itself into safe mode.
So it protects itself.
Right. It shuts down anything non-essential that includes the science instruments, unfortunately.
Okay. Bummer for the science, but good for the spacecraft.
Exactly. And it focuses all its energy on just the critical stuff, keeping power stable and, crucially, making sure it can talk to us back on Earth.
Got it. So the groundbreaking science has to wait a bit just to ensure Juno stays healthy.
Yeah.
And you said this happened twice, right around the closest approach?
Precisely. The timing is really suggestive. The first time was about an hour before it hit Perijove.
Okay.
The second time was roughly 45 minutes after it passed that closest point.
Right, when it would be going through the thickest part of, well, the bad stuff.
You got it. That timing points pretty strongly towards Jupiter's intense radiation belts.
Which are legendary, aren't they? The most hostile environment in the solar system.
By far. And that radiation, those high-energy particles, they're most concentrated closest to the planet. So the early thinking is definitely that flying through these particularly nasty zones triggered the safe modes.
Makes sense.
And, understanding how Juno handles this is super important for designing future missions, maybe missions closer to the sun or exploring other gas giants.
Yeah, you need to know what your hardware can take. It's almost impossible to really picture that level of radiation, what it would do.
It's extreme.
But it sounds like, even with this double whammy, Juno did exactly what it was supposed to do.
Absolutely. The reports emphasize that. In both cases, Juno's systems worked just as designed. It automatically rebooted its main computer, powered down the non-critical systems, and importantly, it turned itself to point its main antenna back towards Earth.
Smart. So it could phone home.
Exactly. Which meant mission control could reestablish high-speed communication, and they did that successfully.
Yeah. Must have been a tense few hours for the team at JPL.
I imagine so, yeah.
So where are things now? Is Juno back to normal operations, or are we getting data?
Well, the latest updates are positive. The team is running diagnostics, basically checking the flight software to understand exactly what caused the safe modes.
Digging into the details.
Right. And they're working on retrieving the data, both the engineering data about the spacecraft's health and the science data that was collected before and after the events.
Ah, so not all the science from that flyby was lost then.
It seems not entirely. There was an interruption during the safe modes, obviously, but they're working to recover what was gathered around those times. It looks like the mission is getting back on track.
That's incredible resilience. And it brings us back to how Juno survives this in the first place. That titanium radiation vault. It sounds like something out of science fiction.
It kind of does, doesn't it? But it's very real and absolutely essential for Juno.
So this is the key to keeping our delicate robot safe in that cosmic blender.
Pretty much. It's built with these thick titanium walls designed specifically to block or absorb those high-energy particles.
So they don't fry the electronics.
Exactly. They shield the really sensitive stuff, the main computer, memory, communications hardware. Those things are particularly vulnerable to radiation damage, data corruption, or even physical damage.
And a hefty piece of kit, right? Not light.
No, not at all. Just the vault itself holding over 20 electronic boxes, weighs about 200 kilograms. That's nearly 500 pounds.
Wow. That's a serious commitment in terms of mass on a spacecraft.
It really is. It shows how critical protecting those electronics is. You can even find pictures from like May 2010 showing the team at Lockheed Martin carefully putting this vault together.
Years of planning just for that one component. Amazing.
It really highlights the long-term effort involved in these deep space missions.
And thinking about that effort, these recent safe modes, they weren't the first time Juno's faced this kind of thing, were they?
That's right. If you count these two from Perijove 71, Juno has now had 4 unexpected spacecraft-initiated safe modes since it arrived at Jupiter back in July 2016.
4 times. When were the others?
There was one early on in 2016 during only its second science orbit, and then another one occurred in 2022 that was during its 39th orbit.
So it's happened before. It's not unprecedented.
Correct. And the crucial thing is, in every single one of those cases,
Let me guess, it recovered just fine.
exactly. Just like now, it performed as designed, followed its safety protocols, and regained full operational capability afterwards.
That's quite a testament to the engineering.
Yeah.
Automated troubleshooting millions of miles away.
It really is. It shows the foresight of the engineers, anticipating these kinds of environmental hazards and building in that resilience.
It's not about preventing problems entirely, because maybe you can't in such an environment.
Right. It's about having robust systems that can handle the problems when they inevitably crop up, detect, manage, recover.
So looking ahead, what's the immediate future for Juno? Do these recent events affect the upcoming schedule?
Well, the next Perijove 72, is scheduled for May 7th.
Okay, coming up soon.
And this next pass is actually pretty exciting because it also includes a flyby of Jupiter's moon, Io.
Io, the volcanic moon. That sounds interesting. How close?
Relatively close, about 55,300 miles or 89,000 kilometers from Io's surface.
Wow. Io itself must be a pretty challenging place to fly past, even besides Jupiter's radiation. All those volcanoes spewing stuff out.
Oh, absolutely. It adds another layer of complexity. Io is constantly pumping out volcanic material, sulfur, gas, dust into space.
Right, feeding Jupiter's magnetosphere.
Exactly. It contributes significantly to that already intense plasma environment. So yeah, the Io flyby needs careful planning and monitoring, even with the vault.
But the science payoff must be huge.
Immense. Getting data that close will tell us so much more about Io's volcanism and how it interacts with Jupiter's whole system.
It's easy to get lost in the technical challenges, the safe modes, and flybys. But maybe we should step back for a second. Remind us, what are the big picture science goals for Juno? Why is it out there?
Good point. Juno's core mission is really about understanding Jupiter itself, its origin, how it evolved.
The biggest planet in our solar system. Got to be important clues there.
Definitely. Also, its internal structure, what's deep inside, how does its atmosphere work, those giant storms, the Great Red Spot, and, of course, its powerful magnetosphere, which creates the radiation belts we've been talking about.
So studying Jupiter helps us understand our whole solar system's formation.
Exactly. And maybe even planetary systems beyond ours, the exoplanets we're finding. Jupiter is a key piece of that puzzle.
And Juno fits into a larger NASA program, doesn't it?
Yes, it's part of NASA's New Frontiers program. These are missions designed for ambitious exploration within our solar system, tackling those fundamental science questions.
And who runs the show, so to speak?
Well, it's managed by NASA's Marshall Space Flight Center, programmatically. The science direction comes from the Science Mission Directorate at NASA HQ.
Okay.
The lead scientist, the principal investigator, is Scott Bolton from Southwest Research Institute. And the day-to-day operations, the flying of the spacecraft, that's handled by the fantastic team at JPL, the Jet Propulsion Laboratory.
Right, JPL. They handle a lot of these big planetary missions.
They do. And the spacecraft itself, built and operated by Lockheed Martin Space.
So it's a huge collaboration, not just NASA.
Absolutely. And it's international, too. A really key partner is the Italian Space Agency, ASI. They provided a major instrument called JIRAM.
JIRAM? What's that?
It stands for Jovian Infrared Auroral Mapper. So it studies Jupiter's aurora, its heat signatures, really important stuff.
Oh, okay. Cool.
And beyond that, many other instruments came from different universities and institutions across the U.S. It's a truly massive team effort.
It really drives home the sheer scale of expertise and dedication needed for these missions. Pushing boundaries takes a village, or maybe a planet's worth of scientists and engineers.
Well put.
So as we wrap up this deep dive on Juno's recent adventure, what's the main takeaway for people listening?
I think the biggest thing is the resilience. The resilience of the spacecraft and the sheer ingenuity of the people behind it. Even when you throw it into the absolute worst conditions the solar system has, like Jupiter's radiation, sophisticated engineering, and really well-thought-out safety plans, let us keep exploring.
Right. The fact that Juno hitting safe mode isn't a failure, but actually proof the safety systems work as intended. That's key.
Exactly. It highlights the robustness that's built into these incredibly complex missions. It reacted just as it should have.
That is a powerful point. It shifts the perspective, doesn't it? And it makes you think. I mean, the cleverness required to build something that survives that.
Yeah.
And keep sending back useful data.
Yeah.
Well, it makes you wonder, what other huge challenges, maybe even here on Earth, could we tackle with that same kind of focus, dedication, and, smart engineering? It's definitely something to think about.
Indeed it is. Makes you excited to see what lessons learned from missions like Juno will lead to next, doesn't it? Both in space and maybe closer to home.